Physical Science. It's Mr. V. I'm back. Been a little absent for a while because I can't do a video without coughing through, but I think I'm about through it. I can do one without having a coughing attack, so we should be okay, I hope. If not, then we're just going to cough our way through it because we are getting behind a little bit in chemistry. This is the third video that we're going to do. There will be a quiz after this video. Alright, so after you see this video, there's a graded quiz. It will be under quizzes in your Canvas. So check in every day, check for the video. There will be a quiz after it. You're only going to have like 5 minutes to take it because there's only like 5 questions. Alright, so quiz after this, check out the video. You can use notes, write down notes, do anything you need to do to make notes, and you can use your notes on your quiz. 5 minutes, there's going to be a frame of time where you can get in and take that quiz. If you don't take it, you're going to get a 0, or you're going to have to do it late for late credit, and that's no good. So let's take it in the time allowed. There should be about 3 days where it's going to be open. All right, so we're going to go for this. We're going to types of chemical bonds. I hope we can do this because there's a bird. I don't know if you can hear it right outside there that's chirping so loud I can't even focus. So come on, bird, quit chirping. All right, we're going to do this. One of the types of bonds that we have that you have to know about is this thing called ionic bonds. Ionic bonds. Ionic bonds are the force of attraction between oppositely charged elements, oppositely charged things. Okay? Now this is what you know about already because we've been talking about oxidation numbers. You know that some of them are positive and some of them are negatives, and in this case opposites attract. Okay? A positive will be attracted to a negative, but what happens is in ionic bonds, one tends to hog all the electrons. Alright, electrons are negatively charged, you know that. But sodium, let's say sodium comes in here, and sodium is a 1+, so it has like an extra electron. It's stable if it loses one, but then it sometimes gets around this thing called chlorine. And chlorine is a 1-, and it's a halogen. Okay? Halogens hog electrons, they're like bullies. So what happens is, these two get together, sodium says, hey, I have an extra one, then chlorine says, hey, I need one, so they form this bond, and then that free electron is basically spinning around, almost entirely around chlorine, because it's not sharing equally. It's saying, hey, I want that electron, I'm going to keep it close to me. Now sodium just kind of hangs around while that electron is mainly around the chlorine because it's hogging that electron. Alright, it's kind of like if we had a high school bully, and the high school bully saw a kid with a lollipop, a 3rd grader. And so the bully goes, hey, I like lollipops. And the 3rd grader goes, well, I've got one. And then the bully grabs it and he kind of holds it like this to keep it away from the 3rd grader from getting it back. That's kind of like an ionic bond. It's a positive negative thing. Dang, that bird. Positive negative thing, force of attraction. One typically hogs that electron, causing what we call a polar molecule. A polar molecule is a molecule with a high positive charge on one side, a high negative charge on the other side. Now somebody, when we did our demonstrations in class, they got a balloon, they charged it up by rubbing it on their shirt or the hair, I can't remember. They charged it, made it polarized. And then we had a stream of water. Who was this person? I can't remember who did it. Stream of water, they moved the balloon close to it, and the water bent because you're trying to attract. It was, I'm sorry, this bird is bothering me. I just can't take it anymore. Hold on. Hold on. Okay. Alright. Now the bird's quiet. Okay. I'm just joking. That was a joke. I didn't shoot any bird. I'm just trying to keep it alive. Alright? That was a joke. You bird lovers, don't get mad at me. No animals were harmed in the making of this video. Alright, let's get back to ionic bonds. Ionic bonds, as you know, positive, negative. Ions, that's the attraction from positive to negative. They tend to make these things called polar molecules. NaCl is a polar molecule because the negative side tends to be the chlorine side. The positive side tends to be the sodium side. Alright, by the way, this is table salt. This is table salt. Sodium chloride is table salt. But also, you have a molecule called H2O. And you all know that this is water. All right, H2O2, by the way, is hydrogen peroxide, but H2O is water. It's also a polar molecule because the hydrogens are positive, the oxygen's negative, and you tend to have it form like this, where you have a positive side and you have the negative oxygen side. It's a polar molecule, and it's an ionic bond between there because it's an attraction between positives and negatives. All right, you got that, right? You got it? Pretty easy. Let's go to the next kind of bond. We have ionic bonds. We also have covalent bonds. Now, if we're talking about relationships and making analogies to these kinds of bonds, I hope the kind of relationships you have are covalent relationships. In other words, there's sharing of electrons in there's equal sharing in covalent. In ionics, you heard about relationships where one is the taker and one is the giver. In ionic bonds, one of the people takes everything and the other one gives everything, and it's like a one-way street. Those tend to be unhealthy relationships, but these would be like healthy relationships because they share everything. These molecules are sharing electrons. Now, covalent bonds tend to make molecules that are nonpolar. Remember, ionic bonds tend to make polar molecules. Covalent bonds tend to make nonpolar, so there's no charge on it somewhere. Let's take for this example of oxygen. You got oxygen, but this is the element oxygen because it's not O2. But now let's make it O2. Now we have a bond between two oxygens, and this is going to mean this is the gas that we breathe, the oxygen gas. Now, they are sharing electrons between them. I think oxygen is number 6 in the periodic table. In other words, the two oxygens you get together and they figure out, hey, we can be stable because they're not stable by themselves. We can be stable if we share our electrons, so we can both kind of keep the electrons close to us and we can be a stable molecule. Remember, all molecules want to be stable, and so it's going to form a nonpolar molecule, and that's oxygen. By the way, it's funny, I'm trying to breathe when I'm saying this. Most of the gas we breathe in, every time we breathe in, is not oxygen. That's like 21% or so. Most of the gas is formed when one nitrogen atom bonds with another nitrogen atom to make a compound or a molecule. All right, and this is going to make N2 gas, which makes up over 70% of the gases we breathe. When we can breathe, by the way, I don't have COVID, by the way, all right? I have winter allergies moving into springtime. Every year, I go through coughing fits when I talk a lot, so it's making videos difficult, but we have N2 gas, non-polar. It's a covalent bond because they're sharing electrons. All right, so these are two types of bonds. I'm about to check off for this particular video. Guys, there's going to be a quiz after this, okay? So it's graded, go take your quiz, but use any notes that you want on this. Use any sources that you want in addition to this. And remember, you animal lovers, I didn't just kill an animal to make this video. It was a joke. I was just joking because I like people to laugh, all right? So this is Mr. V checking out for my workshop. This is PS video number 3. Y'all have a wonderful day.